Quadratics are all about parabolas. It's all about the shapes of the curves. So this says a baseball is hit by the batter. It's modeled by this function right here. And it represents the ball's height above the ground in feet per time per second. Describe how the ball's height above the ground is related to time. Find how long it will take the ball to hit the ground. Okay, so if you think about the fact that here's a ball that's hit by a batter, when the ball gets hit, it's going to go up, and then it's going to come down and hit the ground. The value of 4 in that equation represents the height at which the ball was hit. So what that means is at time 0, the ball was hit at a height of 4 feet. So again, that should make sense. If you're an average of a 5 to 6 foot tall person, your swing heights are going to be about 4 feet off the ground. The ball's going to travel. It's going to reach its max height at a time in the middle. That max height that it reaches is known as our vertex. The height at which the ball reaches the ground is going to be 0. So it says, find how long it will take the ball to hit the ground. Well, the ball will hit the ground when the height is 0. So you're going to set 0 equal to that quadratic function. So at this point, you have a couple options. You could do quadratic formula. You could try to take out a GCF. So you could take the number 130 and see if that divides by 4. So it does not, so you can't take out a GCF. So my suggestion at that point would be to set up a quadratic formula. So that's negative b, so that's negative 130 plus or minus the square root of b squared minus 4ac all over 2a. So 130 squared is 16,900. And then what we're doing is subtracting from that 4 times negative 16 times 4. So you get 16,644 divided by negative 32. So that's negative 130 plus or minus 129 all over negative 32, which gave you that value. We got above, actually I think that's typed in wrong. 4 times 16 times 4. I'm using a goofy calculator. Yeah, 130 times 130 minus 256. I need a real calculator. There we go. So it should be 17,156, not that 1664. I knew the little calculator wasn't working. Okay, so then we're going to put our answer in there. And then subtract 130 divided by negative 32. And you get almost 0. And then you're going to take that same number And you're going to add the 130. So you get negative 130 minus 130, put 981 divided by negative 32. And you get that 8.156 or 8.2. Okay, so a summary of Chapter 5 and quadratics. This handout's going to be one of your best friends to study for Monday and Tuesday. Standard form is y equals ax squared plus bx plus c. Vertex form is y equals ax minus h squared plus k. In vertex form, the vertex is the opposite of h inside, comma k. In standard form, you have to find h and k. So in standard form, h is always negative b divided by 2a. And the y value is plugging that point in. So for k, you have to plug in negative b divided by 2a and square it, and then multiply it, and then add back c. This paper?
Yeah.
No.
What about the front page?
Oh. Okay, when solving, all quadratic equations must be set equal to 0. Good. They must also always be in standard form. When you're factoring, the first thing you want to do is always look for a GCF. And then you want to apply your different methods. So you have factor by grouping. That's for if you have 4 terms. You have a difference of squares. So that's 2 terms with perfect squares. And they need to have a subtraction. And then we're also using our technique, which is magic X. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is what's under the radical. It's b squared minus 4ac. The discriminant tells you the number and type of solutions. If the discriminant is positive, you have 2 reals. If it's 0, you have 1 real. And if it's negative, you have 2 imaginary. Okay, on the back page is all your key terms. So what is the vertex? It is the x and y value at which an object is at its max height or min height. depending on if it opens up or down. The zeros are where it crosses the x-axis. So if you are graphing, this is in what we call vertex form. The vertex would be 2, 3. The axis of symmetry is x equals 2. No, it's always the opposite of what's inside. The A value is a positive 3. So that tells me that my graph opens up. So I have a min. The min occurs at k, so at 3. Domains of freebie, it's always all reals. Since it's a min, the y's are greater than or equal to the min value of 3. Transformations are our words like stretch, compress, right, left, up, and down. So a positive 3 is stretched. A vertex at 2, 3 tells me that it's right 2 and up 3. Since this graph is open up with a min, then there are no roots because it never hits the x-axis. Okay, and then for the back, to simplify, you have to remember your powers of I. So I is I squared is -1, I cubed is -I, and I to the 4th is +1. If it's a plus sign, you add. So that's like 1 plus 11, which is 12, and 6 minus 2, which is 4. If there's no sign, you FOIL. I times I is I squared, but I squared is -1. So that becomes positive 30. So you get 36 plus 3i. And then for powers of I, you just take that number and divide it by 4. So you get a remainder of 0.5. So that tells me that I to the 66 is really like I squared, which is -1. And then simplifying square roots. Anytime you have a negative, it gets an I. And then you want to break the number down into its perfect squares. So 136 divides by 4. (34) is 17 and 2, so it doesn't reduce. The square root of 4 is 2. So you get 2i square roots of 34. Okay, your test on Monday will be very similar to this handout we just did, where you'll be simplifying. You'll need to know everything on that front page.